Welcome to a slow, beginner-friendly lesson on file paths with pathlib in Python, made for absolute beginners. The clean way to paths. Today you learn a cleaner way to work with file paths. So far, you open files by passing a plain string like notes.txt. That works for one file in one folder. But real projects have many files across many folders, and building those paths by hand with strings gets messy fast. Python ships a modern tool called pathlib that treats a path as an object, not a string. By the end you will build and inspect paths with calm confidence. Objects, not strings. Think about what happens when your project grows. You have a data folder, an output folder, a config folder. Each holds files you need to read or write. If you build paths by concatenating strings with slashes, you worry about operating system differences, trailing slashes, and easy mistakes. Pathlib fixes all of that. A path becomes a first-class object with helpful methods, not just a piece of text. Strings get messy. A path is more than a string. It is a small, smart object that knows where it points, what its name is, what kind of file it refers to, and whether the thing it names actually exists on disk right now. A path is smart. Here is the old way, using the os module. You join folder names with os.path.join. You check existence with os.path.exists. You get size with os.path.getSize. It works, but every operation is a separate function on a plain string. The path itself is not smart, it is just text passed between functions. It feels clunky, and it is easy to mix up argument order. The old way works. Here is the new way, using pathlib. You import path from pathlib. You build a path by joining parts with the slash operator, yes, actual slash, but it works on Windows too because path handles the details. The path is now an object. Existence is a method on it. Size is reached through stat. Everything lives on the path itself. One object, many capabilities. That is the core idea behind pathlib. The new way shines. Creating a path is simple. Import path from pathlib, then call path with a string. What you get back is not a string, it is a POSIX path on Mac and Linux, or a Windows path on Windows. The difference is hidden from you. You write the same code on every operating system and pathlib handles the platform details. From this point on, you work with the path object, not the original string. Path is an object. The slash operator joins path parts cleanly. You chain them, data, then logs, then app.log. Pathlib inserts the correct separator for your operating system automatically, / on Mac and Linux, / on Windows. You rarely think about it. If you need a plain string back, call str on the path. Most of the time you do not need to, because path objects work directly with open. Join with slash. Two kinds of paths exist. A relative path starts from wherever your program is running, the current working directory. Notes.txt is relative. An absolute path starts from the root of the disk, like /users/your name. Pathlib gives you CWD for the current folder and home for your user folder. Most of the time relative paths are enough, but it helps to know which kind you are using. Know where you are. Every path has parts. A parent folder, a file name, an extension, and a stem. Once you can see the parts, you can navigate any folder structure with calm. Every path has parts. Take a path like data/notes.txt. It has 4 useful parts. Parent is the folder containing the file, here, data. Name is the full file name, notes.txt. Suffix is the extension, .txt. Stem is the name without the extension, notes. Once you know these 4 parts, you can take any path apart calmly, no matter how deep the folders go. 4 useful parts. Parent gives you the folder containing the file. For data/logs/app.log, the parent is data/logs. Call parent again and you get data, 1 level higher. You can chain parent to walk up the folder tree as far as you need. This makes navigation effortless. Instead of string surgery, you ask for the parent and you get a new path object you can keep working with. Walk up the tree. Name gives you the file name with its extension, app.log. Stem gives you the name without the extension, just app. Suffix gives you the extension, .log. These 3 properties let you inspect any file without parsing strings yourself. Want all .log files? Check the suffix. Want a clean name for a report? Use the stem. Pathlib does the parsing for you, correctly, every time. Read the name. Before you open a file, you often want to know whether it exists. Exists returns true or false. You use it in an if statement to decide what to do, read the file, create it, or report a problem. Notice this is a method on the path itself, not a separate function. The path knows how to answer questions about the thing it points to. That is the object-oriented style you see everywhere in modern Python. Ask if it exists. Sometimes exists is not enough, you need to know what kind of thing a path points to. Is it a file, or is it a folder? Is file returns true only for regular files? Is dir returns true only for directories? Use them together with exists to make safe decisions. If a path exists but is a folder, you do not want to try reading it as a text file. These two methods keep your code honest. File or folder. Once a path can answer questions about itself, exploring the file system becomes calm. You ask, the path answers, and your code stays clean and predictable. Explore calmly. Dir creates the folder the path points to. Pass parents equals true and pathlib creates any missing parent folders along the way, like mkdir-p on the command line. Pass exist _ok equals true and it will not crash if the folder already exists. Together these two arguments make folder creation safe. You can run the same code many times and it just works. Perfect for setup steps at the start of a script. Create folders safely. Glob finds files matching a pattern. Star matches anything, so star.txt finds all text files in a folder. 2 stars means recursive, search subfolders too. Glob returns path objects, not strings, so you can immediately call methods on each result. This is how you process every file in a folder. Glob a pattern, loop over the results, and read or write each one. Clean, readable, and powerful. Find by pattern. Because every operation returns a path, you can chain them naturally. Take a path, get its parent, join a new file name, and immediately check whether that new path exists, all in one expression. No temporary strings, no manual joins. This is the joy of pathlib. Each step gives you back a smart object. The code reads almost like a sentence, and it works the same on every operating system. Chain naturally. Put the old and new side by side. The old way calls functions on plain strings, join, exists, getSize, all scattered across the OS module. The new way calls methods on a single path object. The / operator joins parts cleanly. The same code runs unchanged on Mac, Linux, and Windows. Once you taste pathlib, you rarely go back to os.path. It is simpler, safer, and more pleasant to read. Old versus new. Here is a complete, realistic example. Create a data folder safely with mkdir. Then glob every .txt file inside it. For each file, print its name and its size in bytes. 4 lines, no string parsing, no OS module, and it runs anywhere. This is the kind of code you will write again and again. Set up a folder, find files in it, do something with each one. Pathlib makes it readable and robust. Real and readable. Here is the whole lesson in one breath. Import path from pathlib. Build paths by joining parts with the / operator. Ask questions with methods like exists, is file, is dir. Create folders with mkdir. Find files with glob. Take paths apart with properties like parent, name, suffix, and stem. The path is an object, not a string. Once you internalize that, file operations become much cleaner. One object, many powers. You can now build and inspect file paths cleanly. But text files alone only hold lines of plain text. Real programs need structure, saving a list of settings, a dictionary of user data, a nested configuration. That is where JSON comes in. Next lesson introduces JSON, the universal format for structured data. After that, you learn to read and write JSON files using everything you know so far. JSON is next. If you want to lock this in, try this short exercise. Import path, build a path to output /report.txt, and print its parent, name, suffix, and stem. Then check whether it exists. You should see output, report.txt, and report, and probably false for existence, because you have not created the file yet. Once that feels natural, you are ready for the next step. Build and inspect. Thanks for learning pathlib. Next we meet JSON, the universal data format. Paths are calm now.